Space, the final frontier. For thousands of years, humanity has looked to the sky with curiosity. We've wondered where we fit in the universe. It's not like the interest in what lies beyond Earth is anything new. Humanity has always been full of explorers. Probably one of the best known in history is Christopher Columbus for setting sail across the Atlantic in search for India. Instead of finding India, he found the New World, but my point here being is that he explored. And with exploration comes expanse and knowledge. Thanks to these explorers, there's little more to discover on our planet, which prompts us to look up to the sky. But why should we leave Earth? I think there's a lot of people who would argue that we have comfort here and it's safe. So why would we want to leave and go into a frontier that's so unknown and unpredictable? Well, because curiosity. Curiosity drives our expanse. Humanity has placed a great interest in finding the unknowns outside of Earth, but how do we get to uncovering those unknowns? Okay, so there are a few different types of propulsion systems we can look at that have this potential. There are chemical rockets, which are what we normally use today, nuclear thermal rockets, which started getting popular in the 60s, and ion thrusters, which are on the newer side of the three. I'm going to save ion thrusters for another time, and we're just going to focus on nuclear propulsion for today. All right, so what exactly is nuclear propulsion? Well, in short, it's a rocket that gets its thrust from the heat of a nuclear reaction, which is often fission. Fission breaks the fuel source down over and over and over again at really high temperatures. So the idea of nuclear propulsion has been around since the early 20th century. At this time, radium was being hypothesized to be a potential fuel source for vehicles like cars and planes. So the United States issued Project Rover, which started in the 50s and lasted for about 3 decades. This was the first nuclear project directed towards outer space travel. Okay, so this is a very simplified drawing of a nuclear rocket that was tested in the 1960s. The propellant, which is usually liquid hydrogen, is stored at the top in the tanks. The pump then forces the hydrogen through a piping system, which surrounds the nozzle in the rocket motor. The propellant then enters the reactor, where it's heated and expanded into a gas that's then pushed through the nozzle to create thrust. This isn't shown in the picture, but I think it's pretty important to note that there are a ton of different controls in the nozzle so that the rocket can actually be directed in the right way. Okay, so now you may be asking about radiation, because this is literally strapping humans to nukes and shooting them up into space. So you'd be right to think it's unsafe, which it very much is. In the reactor during fission, a ton of radiation is emitted, which can be really harmful to the crew if they're in contact with any. So finding a way to get them away from this radiation becomes a pretty big problem if we ever want to think about long-term missions with humans. So if we actually want to set them out into space, we're going to have to develop some sort of tech that can protect them. Another downside is that they actually weren't designed to be launched out of Earth's atmosphere. So it's not a complete alternative to what we have now, but they definitely are better in more ways than one. Firstly, chemical engines produce very little power, which makes them require way more fuel than that needed for a nuclear rocket. On top of this, they require fuel and an oxidizer to launch, and nuclear only needs fuel. So because they don't need as much fuel and they also don't need to be nearly as big, they are seen as more ideal. By being both fuel efficient and lighter, they're also much, much faster. Chemical rockets can only go about 17,000 miles an hour, and nuclear can easily double that. So we're looking at going to Mars in as little as 4 months. With chemical rockets, that would take 2 years. Nuclear rockets have the potential to revolutionize space travel, but who's currently making this dream a reality? There are multiple companies working in this realm, but 3 of the most notable are Griffin Technologies, which is an engineering service for the national security, BWX Technologies, which is a nuclear fuel company, and Atmos Space, which is working on emerging spacecraft propulsion systems. In comparison to chemical rockets, nuclear is cost-efficient, lighter, and faster. With continued innovation, the potential of nuclear propulsion will only increase. So maybe someday, even one of us can go to Mars. Thank you.